Hello, everybody. This is my quick overview of Unit 7, Recursive Trees. I'm not going to do Unit 7 right here because BJC has already done that. They have a lot of great text explaining their lab. I'm going to do kind of my own variation on it so you see the concept of using recursion to draw fractal shapes in a slightly different way and in a different voice and in video instead of on the flat screen. Hopefully, that'll be of some benefit. Let's get right to it. So my goal here is to draw a neat little fractal tree pattern. And I'm going to start with the most basic kind of a tree, which is basically just a little twig. So my little tree is going to be move 50 steps, stamp, my little leaf shape. It's a dinosaur. And then move back the reverse negative 50 steps. Just like that. There it is. All there is to it, very simple. And now I'm going to throw this into a block. Make a block. I'm going to call it twig. And rather than have it always be 50, I'm going to give it a size input. Twig size X. And we'll just throw this code right into it. And instead of moving 50, it'll be X. And instead of moving negative 50, it'll be -1 times X. Apply. And I have this very boring, not very exciting code here that allows me to draw twigs of any size I want. That's all there is to it. All right, now I'm going to make an actual tree. My tree is going to involve my little dinosaur going up, turning left, doing a twig, turning back to center, doing a twig, turning right, doing another twig, and then turning back to center and going back to where it started. That last step is important. That's called state transparency. At the end of each one of these blocks running, the sprite should be exactly where it was at the beginning, facing the same direction. That way I don't have to keep track. Each block doesn't move the sprite in some way that I have to keep track of. The sprite always comes back to center, and that's all I ever have to worry about. So let's make the code that does that. So it's going to make 3 twigs. So I'm going to have 3 versions of this. Let's have each of these be size 50, not 500. And this is going to make it move 100 steps, make it move double that. Then it's going to turn left, and let's have it turn, that's turn right. Just do the relabel, love that little trick. Let's have it turn left 60 degrees, move 100 steps, turn left 60, draw a twig, turn right 60, get it back facing the same direction it was, draw a twig, keep turning right 60 more, draw a twig. Then we need to have it reverse, go back to forward and go back 100 steps. So it's going to turn left 60 again. And then it's going to move negative 100 steps, which I'm going to save myself a step later on and just call that -1 times 100. And then this should make a little, there we go. Sure, it's a tree. We can call that a tree, right? I've seen lots of trees that look like that. Looks like a chicken foot. Anyway, there's my tree. Now I'm going to blockify all of this. Make a block. I'm going to call this block tree level 1. Tree level 1, size X. Okay, so I'm going to throw, oops, something happened there. I used a $sign instead of a % is what happened there. We'll just make an input. Tree level 1, size X. So I'm going to throw all of this in here. The X is now these 200s. These 50s are now half of X. So I'm going to throw a little X divided by 2 in for each one of those 50s. Okay, let's see if this works the way I think it's supposed to. So my tree level 1 size 100 should draw exactly what I have right there. Sure, if I make it smaller, size 50, looks good. If I make it bigger, size 200, excellent. That's working exactly the way that I think it should. Notice how each time the little dinosaur comes back where he started. Now I'm going to make a tree level 2. What the tree level 2 is going to do is it's going to go up, turn left, go forward, draw a whole tree level 1, turn back to center, draw another tree level 1, turn back right, draw another tree level 1, and then go back to where it started. So each of those tree level 1s will itself have 3 branches. So let's put that together. So it's going to go forward, call it 100 steps. It's going to turn left 60 degrees. It's going to make a tree level 1 size 50, half the 100. Turn right 60 degrees again. Make another tree level 1, also size 50. Turn right another 60 degrees. Make another tree level 1, also size 50. And then state transparency, get back to where it started. Reverse that last turn and move. And again, I'm going to make this -1 times 100 to save me a little step later on. All right, let's see if that works. Ooh, look at that. I'm getting my tree level 2 with all of those various turns. Starting to look a little bit like a snowflake. Maybe a Coke snowflake, looking ahead at some future projects. All right, now let's blockify that. This is a tree level 2, size X. And I'm going to throw all of this code right into here. Again, those two 100s are going to turn into an X, and those other 50s are going to turn into an X divided by 2. Now, before I go any farther, let's ensure that this block is working exactly the way I want it to. If I do a tree level 2 size 100, I should get exactly what I just had. Indeed, if I do it smaller, size, say 50, perfect, working exactly the way I want it to. Now, at this point, you may have noticed something, that my tree level 2 and my tree level 1 are exactly the same thing. They are completely identical, except for the fact that tree level 2 includes a tree level 1 and tree level 1 includes a twig. But aside from that, they are precisely the same thing. So there's no reason to keep adding more blocks if these are really all just the same thing. Let's take my tree level 2 block as a starting point, and I'm going to change this from tree level 2. I'm just going to make that level 2 an input. I'm going to call it n. So this is now a tree level n block. I'm going to apply that. And then instead of it doing a tree level 1, it's just going to do a tree level 1 less than n. If n is 2, the next one will be a level 1. So that's going to be a tree level n minus 1. So all of these tree level 1s are going to get replaced with a tree level 1 less than the level I'm on. Drop the tree level 1. Ooh, I'm sucking at this right now. There we go. Replace it with the tree level n minus 1. If this is a tree level 10, that'll do a tree level 9. And it'll work its way all down. With one exception, a tree level 0 is a twig. And nowhere in here will it actually make a twig. This tree level n minus 1 will just repeat this block. So I've actually taken the twig out of it. And let's see what that looks like in practice. If I wanted to do a tree level 2, let's get this out of the way. If I wanted to do a tree level 2 size 50, it should look exactly like what I have there, except that I've messed the twig thing up and instead it does that. And I get the spinning wheel of death, where what it's doing is it's moving forward, turning left, doing a tree level 1, which involves moving forward, turning left, doing a tree level 0, which involves moving forward, turning left, doing a tree level -1, which involves moving forward, turning left, doing a tree level -2, and so on forever. It's probably on negative 500 by now. All right, let's stop this. Go back where I started. So what I need to do is, if the level it's on is 0, it doesn't do the rest of that. It just does a twig. So I'm going to put all of this. There's a few ways I could do this. I could do an if-else block, and I could say if level equals 0, if n equals 0, do a twig. Otherwise, do all of this. That would be one way to do it. If n equals 0, do a twig size, probably should still be size, well, let's make it size x. Do a twig size x and see how that goes. Otherwise, do a tree. I could do that. I could also have one giant if block where it just says, if n is greater than 0, do all this. And if n is not greater than 0, it must be equal to 0, and I can put the twig at the end to only apply if n is greater than 0. So that would look like one big if block. I'd have the n greater than 0. All of this code would go inside of it, and then the twig would go at the end of it. So if n was not greater than 0, it would end up doing a twig. Otherwise, it would do all this. That would work too. I like this for no particularly good reason. Let's see what this does now. There it is. What if I do a level 2 size 150? Let's clear this. What if I do a level 3 size 150? Ooh, what if I do a level 5 size 150? Oh my goodness, now this is starting to get actually making some kind of interesting patterns there when it's done. So this is recursion. These are my recursive trees right there. Let's shrink the size a bit, add even more levels. Let's make it level 10. And let's shrink the size of the sprite just so the leaves don't take up too much space. And this will be a while. Each level I add exponentially increases the amount of time that it takes to run, really triples it because each level has 3 more sublevels in it. So I'm not going to let this go until the video is over, but if I throw this in a warp, I should get a nice little picture of what this actually looks like. Still takes it a while, even under warp. That's how complex these operations can get. So there you go. That is Mr. Agnew's little introduction to recursive trees. I hope that plus BJC is helpful and explains the general concepts. Let's open this guy back up. Everything's running slowly now because I'm taking up all my bandwidth drawing those trees. So you can get a little picture of what that might look like. Apply this to BJC and best of luck on the recursive lab.